All right, welcome back to another Mr.G's EV Hangout. I'm so lucky to be part of the electric vehicle community. This is the place where you convert your car or your truck over to from gas to electric. Doesn't mean we don't like gas, just means like we like going faster, quicker, it's all DIY stuff. We're all helping each other. We got some great people in the house, so just ask everybody to say hi. So Tyler Joy, how you doing?
Hey.
All right. Tyler, you got that truck behind you. Just give it a point so people can see it. You got to say ta-da.
Ta-da.
There you go.
Is the number 666? Did you really get that?
Yeah, we're changing to number 9, but
Yeah, good stuff.
I mean, when you flip upside down, does it change to the number 9?
What's it? Oh, right. Yeah.
I think when you flip upside down during a race.
Yeah. There you go. Well, we got Nick C. Nick, you're part of the project, right?
Yep. Hi, everyone.
All right. Thanks for joining us. Talik, co-host. How you doing?
Hey. What's going on, Mr. G?
All right. And we got the excitable Tom Summers is coming to us live from the bus that we built last summer.
And when we do check-ins with our projects, I got a project to show you here at the garage.
Oh, okay, cool. Yeah, all right. Okay, we'll rotate toward you. Oh my God, what is that?
Hey, I got this friend that always talks. He's obsessed with options. So we're looking at some options here. We don't know what we're going to power it up with. It's either going to be ICE or it's going to be electric. But listen, guys, I'm gonna tell you about this right now, real quick. We've been talking about building another car, and we've been talking about building a training table. So I'm thinking, why not make the car the training table? So,
dude,
yeah, what do you think about that?
That's a great idea.
You can remove the whole back, and that's your training table. You bring it inside, and then you wheel it back in, and tighten 2 wing nuts, and you're all rolling again. 2 very big.
And listen, guys, we can tear it down and build it back up as many times as we want. We can drive it around to different places. All of the stuff can be right here.
I like it. I've been talking about that for years. Roll it in on gas, swap it out in a week to electric, then swap it back for the next class. Rinse and repeat. Go, go, go.
Yeah, and not only that, it's like, look at the accessibility here.
Oh, yeah. That thing's there. Yeah. And we could put the deck right there. And, what is that thing, like a pickup truck Beetle?
Yeah. We give them a lot of different names, but we just, basically we just cut them off right here. I've heard them referred to as El Cavocho, which is kind of like a combination El Camino and a Bocho, which is Mexican for Volkswagen. But it's a regular Volkswagen.
This is crazy, man. This is
crazy. So
I love it, Tom.
Like I said, I got this friend that's obsessed with options. We got options.
Yeah, man. I like options.
Hot swap your power source.
Yeah. So this is cool. That's why we do this show, to see what all the projects and people are doing. Let me get around the table still. Thanks, Tom. That's awesome. We'll come back to you for the more. John Lane is in the house. I think John Lane is part of the Datsun EV project. Is that right? Okay, he just has to unmute himself, or if he's busy or whatever. Minimize his voice. Oh, okay. He said he doesn't want the AI bots to clone his voice, so he's not going to unmute.
It's going to be mute, yeah.
The overlords will.
You're not getting your text here, so okay.
I think it's too late, John. If you got a cell phone or a Wi-Fi, I think it's too late, bro. But anyway, yeah, I saw Silicon Valley. I understand, Anyway, we also got great people in the house. Sarah Lyons, how are you doing? Give us a shout. Okay. All right. Sarah's here, and she is.
All right. I'm good. I'm good. Sorry, I disappeared. Good to see her. Thank you.
Okay. Sarah, thanks for being here. She's got a great project. She's in the middle of converting a Suzuki Samurai. Pretty cool. How's it going so far, Sarah?
Pretty good. I just started working out motor mounts.
Oh, yeah.
And also got the dash out. Yeah, that was a big project. So,
nice. Yeah. Oh, the dash. Yeah. Looks like you stole it now, probably, right? Wires everywhere.
Oh, yeah. Yeah, definitely.
I remember I did the heater core on my Ford Ranger years ago. You pull the dash back, it looks like you stole the thing. Like it just looks like it was left in the South Bronx after you lost it in the parking lot one day. You go like the police recovered it. It's just a disaster. Anyway, I guess that's an East Coast thing. Anyway, so
I can relate.
Yeah. Jersey East Coast thing. Anyway, we also have amazing Mavericks in the house. How you doing?
Yeah, good. Nice to see you again, guys.
Maverick, I'm so sorry. It's Alex, right?
Yeah, I'm Alex.
Oh, I remembered. Perfect. Alex is on fire. He is like shot out of a cannon. This guy's bringing in amazing components. Alex, thanks for being here. If anybody wants to see more of that, check back in my YouTube channel about all the cool stuff that Alex is bringing in. What's the latest? You want to give us the good word? Are you settled in your new showroom in Texas?
Yeah, just finished my showroom and office, and Terry and Jimmy just visit here about 2 days ago, and show all the new product to them, the new motors, new rear drive unit, and the new OBC to Terry and Jimmy.
Nice. And these guys tonight, the featured guests, have a Datsun EV with a net gain. But if they want some more horsepower and they can handle putting in the 400 volts, you guys have Alex, can I say you have basically a Tesla clone, but it's fresh, it's new, right? Is that a good way of putting it?
Mm-hmm. Yeah.
Okay. We'll pull up your website in a sec. And is it? Oh, you have to have 400 volts. Is that right, Alex?
Yeah.
Okay. Okay.
Mm-hmm.
Very cool. So, and we also have Justin. I forget which YouTube or Instagram. Justin, how you doing?
Homebrew.
Right? Homebrew. And you were making the drawings. Your drawings are a lot better now.
Yeah. Thank you. Yeah, still working on the Spitfire. I went to visit my machinist. He's pretty much set with the adapter plates and the coupler, so getting ready to test fit all that stuff. Yeah, I also I started working on a website. I don't want to say what it is yet, but I'm hoping it's going to help our DIY EV community. So maybe I'll share with that on one of our upcoming meetups here.
That would be great. That would be so cool. Yeah, man. Let me tell you, rising tide lifts all boats. I really enjoy working with everybody. I learned something from everyone. Even my day job is I teach high school auto and metal shop here in Jersey. We are doing a DC to AC system off grid, and I'm assembling my first AC breaker, and it's surprising. Like I just never did it. I always work with DC, and so now I'm doing an AC breaker, and I'm learning. You got your hot leg, your neutral, your ground, and then if you got 220, you got another hot, and the colors are all different from DC. So it's a lot of fun, So every project you do and every person you connect with, you're going to learn something, pretty cool. Right. So let's dive into it. You want to start? Can we start with Tyler? You want to tell us first of all, what project is this? You want to just give us like an overview?
Yeah. So I think you guys might have touched on this before, but Lemons has a bounty out for the first EV to win a race outright win 50K in nickels.
Mhm.
1 million
True.
nickels.
Oh yeah. And you guys entered?
Yep. Yeah. I guess from our standpoint, we're not really in it to win the prize. This is more like because we can. So
Now, where does this take place? Like, forgive me, I'm completely naive. Like, where do they race? Like, where do you go?
yeah, so Lemons is all across the country. There's usually 1 or 2 races a month. And the whole idea is it's $500 or less vehicles. Go out and run them to the ground. So
And
Oh,
then
wow.
the idea is they're 24 or 12-hour endurance races. So obviously typically in an ICE you go and you drive your hour and a half stint or whatever, and then you swap drivers, fill up with gas, keep driving. So normally teams have a few 2 to 5 drivers or so as they try to drive through the 24 hours, and typically break about everything on the car along the way.
So for the $500 limit, is that the original car price? Because obviously an EV build is going to be way more than. So how does that factor in with the rules?
Yeah.
so go ahead, Nick.
Yeah, so the $500 is kind of supposed to be the buy-in price of the car, but doesn't include any of the safety equipment. So things like your roll cage, your harnesses, your seats, your fire suppression, all of that doesn't count as part of the rules. And then the special EV rule is the drivetrain is also exempt from that $500 limit.
Okay.
So really kind of the idea behind the EV challenge is to start with some, Lemons quality car and then kind of do whatever you need to do to turn it into an EV.
Got it. This sounds awesome. So where's a
Hey.
list of the tracks? Because maybe this is what we do this summer. I don't know.
The Lemons
Hey,
Cup.
hey, Ron, can I jump in, Ron?
Yeah.
I stumbled into a Lemons rally one time up in Oregon with my VW bus. And my impression, this particular Lemons rally was they were also picking up trash in this, I believe it was a state park up in Oregon. And I got the impression that a lot of people were really kind of lying about their $500 vehicle. It really just needs to look like a $500 car. So in that case, I qualified.
Wait,
I think,
yeah.
of
So
course,
how do they
everybody's
know?
trying to stretch the rules, and you want to keep with the spirit of it. But
Yeah, so how do they know you spent $500 on it?
So at the beginning of the race, there's a tech inspection for safety and all that, and then there's a secondary inspection. I forget exactly what they call it, but it's basically to look at the overall value of the car and the vibe and the parts that you've put on it. And if they do deem that there's probably a lot more than $500 in the car, they'll give you lap penalties. So you start the race maybe negative 50 laps or something.
Oh, okay. Okay, I
So there's
see.
definitely some cars that show up that are more than $500, and they are starting many laps behind, trying to catch back up to the rest of everyone.
And
they
now,
give you they'll give you penalties that are meant to be embarrassing or deriding, right? I mean, there's a very comedic theme about this whole thing.
Yeah, it's very much kind of a lighthearted, fun community, and Tyler and I we did a little bit of endurance racing back when we were in college in an old Camaro, and I think we just love the kind of community around just trying to get these trash heaps through a huge long endurance race. It's a really fun community where everyone's helping fix the cars and keep everything on the track, and so you can get to the end.
that is awesome, man. I'm excited about this. So how did you choose? Okay, so now this is the race. Now, how long have they been doing 24-hour lemons?
Since 2006, John just posted in chat.
Okay, all
So
right.
it's been going on a while, and there's been a couple EVs. I think we're the third EV that's entered, trying to win. Just so we're hoping to see more and more EVs out there too, because we think it's definitely a different challenge than the ICE cars.
Yeah. Okay, now how did you end up choosing? How'd you end up choosing the Datsun?
Well, back in the day, Nick and I were actually both living in California. Had a little bit of burnout from work and ended up wanting to go buy something as like a little burnout project. Went up to Oregon, purchased it, died halfway home, and it sat next to the house for months. But I think it was around that time that Lemons actually came out with their EV challenge, and things just kind of started coming together slowly over the next few years. And two ICE motors later, and I decided it was time to make it electric and go racing.
Wow. Now, before we get too much further into the vehicle, what we want to go into the background a little. Tyler, do you want to tell us a little? Are you someone who worked on electric vehicles? Did you have a shop class in high school? What's the background story?
There's a lot of background there. Yeah, I guess from a racing standpoint, been lucky enough that my dad put me in racing when I was young, so kind of grew up around go-karts and race cars, helping him wrench on stuff. And then I went to college for mechanical engineering, and Nick's an EE, so we kind of have the whole field covered for that. Yeah, I'm actually a mechanical engineer now, doing test equipment for electric motors. So it's not a perfect translation, but it helps.
Did you say test code?
Test engineer.
Oh, test engineer. Oh, do you break stuff for a living?
Pretty much. Other people design it, and then I figure out how to break it in the right way.
Oh, that's pretty much racing, actually. That's good stuff, man. You're the perfect candidate to do this.
I don't know.
Nick, how did you get into this mix?
Yeah, so I've always been into electrical stuff, and back in high school, Tyler and I actually went to high school together. We did some robotics and science Olympiad stuff together, and then we in college we got into racing. Tyler dragged me into that world, and got to do a little bit of endurance racing with the Camaro we had. And then when we were living in California, we stumbled across the series called the Power Wheels Racing Series. I don't know if you guys have seen that. It's
Is this part of Maker's Fair?
Yeah, exactly. So we built a car together for that for a couple of their events, and we're like, hey, well, if we could build a little electric go-kart, we could probably build a full-size car too, right? It's just the same thing but bigger.
You know, it's funny. We were just talking about how it is the same thing. It's motor, controller, batteries. Okay, yep. Sure. Management, battery management, charging, adapter plates and stuff like that. But the concept is the same. Would you agree?
Yeah, I think absolutely. We both kind of, or at least for me, I really enjoyed building the Power Wheels cars, and I think it at least triggered the idea of like, hey, it's a pretty much a similar approach, just much more complicated, full size. And Tyler and I had discussions over a couple of years of, I think the math might work, and then I don't think the math's going to work, and then I think we can make this happen, and I don't know. And we've been slowly convincing ourselves that this is actually a feasible concept for a long time.
Oh, that's so funny that you say the math didn't work or the math worked. I didn't even check the math. We just went and did the conversion, and then I got stuck a bunch of times. So no, but this is great to hear, because I as a shop teacher, if there's other teachers out there listening, the robotics classes and the small go-kart classes, those are important because they do lead to bigger and better things. It's a cheap way to learn fast. That's cool that you mentioned that. Was it Vex Robotics or First Robotics?
We did Best Robotics, right?
Vex, VEX.
I think it was First Robotics.
We do.
First is like unlimited.
We did. I think we did First Robotics one year, but it was Best, BEST.
Oh, okay. That's
Robotics, which that was an interesting one because our school didn't have really the budget to compete in First Robotics. And Best Robotics is a much more inexpensive competition, and you have to use the materials they provide you. So there's no advantage to spending more money. We found that a lot better with our smaller budget at our school.
So it seems you kept the same theme: small budget and in Le Mans, limited budget. I like that idea.
Yeah, I got to keep it scrappy, then break stuff, figure it out, right?
You learn a lot that way. Absolutely. Okay, and John, John can text us how he got into this. You know, send us a little paragraph and we'll read it over here. I got to tell you though, I think the AI already got you. I might be an AI. You never know. I'm scheduled to get a chip put in my head next. You know, so you know, why fight it? Actually, I was late to get a smartphone. 2016. It was my first smartphone. I resisted. So when you know, so people are resisting gasoline over to electric, and they're like, "Yeah, it's not gonna work. I refuse." And I'm like, "Yeah, you'll get there. Right now, you're refusing." But anyway, so that's pretty cool. And okay, John's been racing. A Fiero. Okay, that's cool. Fiero in Lemons with my brother and buddies since 2011. Interesting. Now that's funny because I actually owned a Fiero, and it was converted over to electric by someone in California years ago. Actually, probably 2012, and it was an AC motor, so it was, you know, HP EVS and Curtis controller and you know, lithium iron phosphate batteries, and they sold it to a schmuck in Jersey, and then I bought it. So I'm the second schmuck, and but anyway, so when I bought it for a song, like $1,800, but the whole thing was worth definitely like $25,000 or $30,000. The car was great, but then I had to move, and so I sold it quickly. I sold it quickly over to the original owner, and so that was pretty cool. John, the link you sent kind of is like a broken link or something. I'm not sure.
Sounds like you and John got to convert that thing so we can have a drafting partner at the race.
Yeah.
Dude. Yeah, man. I'll tell you what, you could put the batteries down the center. That would be pretty cool. And then if you did that, you would have a lot of space, you know.
And all that space up front too. And Fiero is a good candidate.
Yeah, 100%.
As long as you can either charge fast enough or swap them. Which
right. So okay. So now let's see. So let's get into the build. So you got the car, and then how did you guys approach this? You sound like you used some math. What'd you guys figure out?
Yeah, so this started out with just an unbelievable amount of math and just guess and check. Essentially, we looked at what the average pace was of all the other racers, try to like back calculate how much energy per lap, what we need for regen, and then figure out our battery capacity from there. That took quite a few iterations of like finding lap times. I think we settled on the Spec Miata lap because we're gonna have to stop every hour or so, which is quite a bit more than any other competitors. We have to be faster on the track and then swap packs faster than people can fill up gas. So
oh, I see. And you went with a pack swapping situation.
Yep. Yeah,
so you're not charging.
We will be charging, but off vehicle.
Interesting.
Yeah, so the plan is to use
packs do you have then?
Yeah, the plan will be to run 3 battery packs. So 1 in the car, 2 charging at all times. And then we'll have sort of a conveyor of swapping those packs in and out.
How many kilowatts is each pack?
We're just about 36 kilowatt hours. We're going to use about 80%.
Okay. All right. So it's like a 1/3 Tesla for every pack.
Yep. Yeah, that's more driven by how quickly we can charge and how quickly we use it. So efficiency is the name of the game.
Okay. Very interesting.
You got roughly 2 hours to charge 1 pack.
Yep.
To 36. Yep. Okay.
Yeah.
Because I think that's the trickiest thing. I mean, the only way to do this is with swapping. for a 12 or 24-hour race. I mean, you're not going to
Yep.
be carrying 17 tons of batteries with you.
No.
Yeah, I think at one point we were close to a megawatt or something ridiculous of batteries if we didn't want to charge. Like it's just not feasible unless you're charging.
Okay,
Yeah.
I got it. Yeah.
Yeah, we'll see if
Go
we can
ahead.
get away with the 3 batteries. You know, if ultimately it turns out we can't quite charge fast enough to keep up, you know, we can always look at adding another battery to the rotation, but that's at least going to be the first target.
Oh wait, I'm a little confused. I thought you guys already went and raced this. Is it in development, or did you already do it 24 hours?
So that first race was just the main goal to show up and pass tech. Everything else was just extra. So we showed up, passed tech, did a few laps, charged. Like basically that just showed us that we could do it, and we could do it in a safe enough manner to race.
This is Apollo 1.
Right.
Yeah.
Right.
I guess there was no point spending a lot of time and trouble doing this if tech is going to say, this is illegal, this is not safe, whatever it is. So yeah, I guess that was a good safe first step.
Yeah, and I'm sure, as you guys know, like most of the cost in this is going to be in batteries. So this meant we could get one battery pack, go test it, make sure the math is right, and then put all the money into getting more batteries.
Oh, I see. Good idea.
And a charging setup that can juice them up fast enough, because this is faster than your level 2 normal charge.
Yep.
Right.
So
Yeah, and so
yep.
yeah, so John Lane has been really helpful working with us, and we've been working with, you know, the Lemons folks to understand what they're looking for in terms of safety and rules, and then we've been kind of working with them to figure out and develop the rules into what they need to be to be safe. So we started from the EV rules for the Pikes Peak Hill Climb was sort of the starting point, and then we've modified the rules a little bit from there for Lemons use.
So now what kind of charging situation are you doing? Like how many watts are you charging with?
You remember off the top of your head, Nick?
So I guess the first thing to say is we built a much smaller charger for the prototyping, right? So we've been able to go out and do track day and then do this first Lemons kind of proof of concept race just with a slow charger. And we still need to design and build the full speed charger for the race this summer. So that's really the last, to me, like major design hurdle we have. So I think we're planning on running, essentially we're trying to max out the current capability of the RV ports that we'll be charging from, right?
Yeah, so we're going to have 4 50 amp 240 volt ports. Then we're basically using like onboard chargers in parallel. Specifically hoping to use the Thunderstruck motors. I think it was a 2500. Trying to use 8 of those guys in parallel.
8?
Yep. And there's going to be 2 of those banks. So 16, I think it was 16 total chargers what we need at the end of the day.
Yeah, and part of that parallelization is needing to use multiple RV plugs. So we're not necessarily going to be running them all at full capacity.
So how much is 8? Is that 20 kilowatt?
I did some math of like, so it looks like 38 kilowatt. Is that what you're doing? More or less, like 40 amp times 4 times 240.
Yes, but it's 2 separate chargers, so about 18, 19, I think.
Yeah, because we're charging 2 batteries at each point in time, right, Tyler? So it's half the charging each.
Wow. All right. So let me get my head around this. Wait, Tyler, you understand this?
Yeah. So they're getting close. They're kind of doing like low DC charging, but with AC components.
Yeah.
Oh.
Well, and I was told that's what the guts of a supercharger station are anyway. They're using, or at least they were at one point, using Tesla onboard chargers, but in a cabinet. Somebody can tell me I'm full of poop, but
whoa. Okay, my head exploded. Can we slow this down just for a second? So you have you're getting AC from the RV park.
Yeah.
Okay. And how many plugs you got available to you?
4 50 amp plugs.
Whoa. Okay. And did you have to arrange that ahead? I mean, what if there's another EV team there?
It's a rental, so ideally in the future we'd have some dedicated ports, but for now we're just renting RV spots.
So you had to rent 4 spots.
Yep.
Yeah. And as John just pointed out in chat, Button Willow and Laguna Seca both have Tesla superchargers at the track, but no other track that at least I'm aware of has superchargers at the track. So we really had to plan on using these RV ports, especially in Colorado for our local track.
Yeah, I mean we're running 144 volt architecture. I think that's 42S. Like we don't have the high enough voltage range to be using like a CHAdeMO or like a Tesla charger or anything like that. Like we basically have to do a custom charger.
Okay. And then, so you got 8 chargers hooked up to the 4 plugs. And then on top of that, that gets turned into DC. And then you're using that to DC charge, obviously DC charge the batteries. What is the final kilowatt that comes out for one battery?
Do you mean like power output on the batteries?
No, for like once you get past the 8 chargers, from the 8 chargers to the battery, what's the how many kilowatts are you putting in the battery?
Like what is each battery getting into the pack?
I think we're pushing 18 kilowatts.
18 kilowatts?
Yeah.
Yeah.
Okay.
Okay, so that's a 2-hour full charge.
Right. And if we think like using 80% range, it'll give us enough time to wheel it out of the car to the charger and wheel it back, essentially.
Wow. This is amazing. This is so amazing.
Yeah,
It's
One very much changing tires. Your pit crew is going to be swapping batteries.
Yeah.
Oh yeah. Like pretty unrealistic, but we're hoping we can get a battery swap and a driver swap in about 5 minutes from pit entrance to pit exit. So
when is your
so that's
go ahead. Sorry, Nick.
Yeah, I think that the battery swapping and charging is really the biggest problem with endurance racing and EV, right? And I think from our point of view, that's still the biggest problem that we have to solve. Like Tyler said, we're going to be stopping slightly more frequently than an ICE car, and so our battery swap has to be faster than a fuel fill up. And when you're racing, the fuel fill ups it's not from a pump, it's from like a jerry cans over the pit wall. But still, somehow we have to be competitive with that, couple minutes time frame with a full battery swap.
So you're not just creating the truck that's got to do the race, but you also have to create your own infrastructure situation for charging.
Yeah, the truck is going to be probably the easy part. It's the logistics behind this at the race. It's going to be the hard part.
Wow. Tom's got his hand up. Tom, just unmute yourself. Go for it, man. Oh, you're good. Go ahead.
Yeah. Okay. So these packs must weigh a lot. How much do they weigh? What kind of chemistry are you using? And where are you putting these packs? I'm assuming the bed of the truck, right? Oh, I see. Yeah, I do see.
Yeah. So I guess from a location point of view, I can touch that, and then Tyler, maybe you can touch on the actual packs.
Yeah.
So the module itself, as you were showing there, it sits in the bed of the truck. We try to get the weight, centrally located and as far down as we can. And then the whole bed is on a pivot that pivots over the rear bumper, and the batteries on sliders, so that you can actually pop up the bed and slide the battery in and out onto like a hydraulic lift table.
Here, I can open this thing real quick if you guys want to see it.
Oh, absolutely.
Yeah, that'd be great.
Let me stop sharing. It's like a shop tour. This is great.
Yeah.
Do it, man. Hey, for those who want to be a bigger screen, just pin. Wow. Oh, I see. And then
Lambo
slide it out sideways.
Wow.
Yeah, exactly. So you could basically slide out the battery onto a table one way and slide in the new battery from the other side of the truck.
Yeah.
Was that part of the choice of the truck?
It wasn't the original intention. Originally, it was going to be out the back, but our weight distribution was getting dangerously close to like 80-20. It was going to be very difficult to drive.
While doing wheelies the whole time, yes.
Yeah.
So right now, I think the pack so it's a little empty because we're doing a revision, but I think the latest rev is going to be about 500 pounds. And then we're sitting at 40, 60 weight ratio right now. So it's a little tail heavy, but because we're rear-wheel drive, it actually should help us.
Wow, this is wild.
Yeah, and then the pack itself, I think we have a picture if you want to share.
Oh yeah.
Of the inside. So we're running 14 of these LG Jaguar I-Pace modules. Each module is a 3S2P. So our overall architecture is 42S 4P.
Where do I have that? Oh, right here.
Yeah.
It's a 3S 4P, right? 12.
Yeah, sorry. Yeah. So 42S 4P overall architecture.
And then it's all, you don't have any liquid cooling in here. Well, maybe you do. What is that?
Yep. There's liquid cooling out the side. I don't think I have a picture for you guys. Actually, yeah, you can see it right there.
Yeah.
Okay, so that plugs into something on the car, a radiator and fans, I'm guessing.
Yep.
And then do you have to cool, you're charging it also?
Yeah, actually, we'll have to cool when we're charging. We don't necessarily need to cool when we're running because we're actually pulling less power than we're charging with.
Oh. So is it? Yeah, go ahead, Kevin.
So so you have a radiator. I'm thinking of this whole setup. You got this thing, you run it to a cart, to your RV stand, you plug it in, you plug in the radiator, you get everything flowing, you check for leaks and turn up the power.
Yeah, so we'll have quick disconnect connections on the coolant lines, and then we have this it's an Anderson I think it's intended for forklifts, but the main connector. So it's got
those big
you got the the 2 high voltage connections and then 8 low voltage connections on it.
Are these the chargers right here that I'm looking at?
Yeah, that's Rev 1 of the charger. Yep.
And is that just 3 that I see there?
Yeah, that's right.
Yep.
And you upped it. You're like, it's not enough power.
Yeah.
Yep.
We had a little generator and it couldn't even run all 3. We actually only charged with 2, so it doesn't take a little bit of power. Do you guys want to see the engine bay and where the radiators are?
Yeah.
Yeah.
100%. Let me stop sharing. And just you want to get more into his picture there, just pin his little box on your video. Oh wow, look at that. Go ahead, tell us what we got there. Point to stuff and tell us stuff.
Yeah. Hard with the computer. So if I remember correctly, I'm trying to remember where we got these, Nick. I think these came from not Zero EV, from EV West.
Yeah, they're the smart car ones, right?
Yeah, that's right. There we go. Yeah, so just smart car EV radiators, and one for the inverter, one for the battery. And then this whole thing will be like shrouded so we get some good airflow.
That's pretty cool. And what is this? Is this kind of like a molded? Is that the original sheet metal, or is that like a molded?
Oh, here. A little easier to see from the cab. So we don't have a transmission, so there's no trans tunnel. And because the Datsun 620 is so small, we needed to open up the footwell. So that's actually all footwell in there.
Oh, okay.
Not sure if you can see it.
Shine a light on that.
Yeah, here, give me just a second.
Yeah.
Yeah, one of our drivers is quite tall. I think he's over 6'5", and so getting him to fit in the Datsun was a bit of a challenge. So the seat is mostly center mounted. And then we have, like Tyler said, we cut into the engine bay and built a sheet metal kind of footwell to get the additional legroom we needed.
Oh.
Wait, so are you in need of drivers?
Yeah.
I mean, yeah. If you're willing to sell
batteries,
well, we need drivers too.
They need battery shovelers, like
battery Sherpas.
Yeah.
Yeah, absolutely.
Sarah, what do you think of this crazy project so far?
I love it. This is fascinating. Thank you for the tour. I've always wanted to go to a Lemons race. I have friends in San Francisco who are into it, and this is really, really fun. So yeah, show us more.
Nice. Super cool.
So your BMS is swapped out with the batteries? Do you have BMSs that live on the battery box?
Oh yeah, I was wondering that too. And
This is all you, Nick.
Yeah. So we're running the Orion 2 BMS, and it lives in the battery. So in the battery, we have the 14 LG modules, and then we have the Orion BMS, and we have a maintenance kill switch that will separate the pack mid-pack, and then we have contactors which the BMS controls, that keep both positive and negative from contacting the connector until all the safety stuff is happy. So we have a 12-volt signal and a safety signal that comes from the car. So the 12-volt signal comes in from the 12-volt battery, which we run in the vehicle, and that stays in the vehicle. And then there's this sort of safety signal that runs through our kill switches and is controlled by the inverter, such that when everything's happy, that 12-volt signal comes back into the pack and will be one of the things that triggers the contactors along with the BMS's safety ready signal. So we try to have like redundancy on safety and make sure there's no way that you could have the pack live while you've unplugged the connector. So the connector itself, it has 8 low voltage signals in addition to the 2 main high voltage signals, and they disconnect first. And since that 12 volts directly drives the contactors in the battery, there's no way that you wouldn't lose the contactor as you unplug the connector. But yeah, so we'll have a BMS on
the low
each.
voltage. Your high voltage is cut off automatically. So
Right.
you should probably have an indicator light to see if that any contactor has welded itself shut. But
Yes. So that's a Lemons rule as well, that you have high voltage indicator lights. So they sit. There's one that's on the pack, one that's on the roof of or 2 that's on the roof of the car, and one that's going to be in the high voltage junction box in the back. So we have indicators kind of anywhere that we think you might need to see it.
so, I mean, if you were able to finish a race, a 12-hour race, do you win that $50,000? If you were the first, would you be the first one ever to finish a race in an electric car?
Yeah. So my understanding that the first 2 EVs that have raced have been more or less kind of lead acid batteries slapped in a car kind of for fun. And one of them has actually made a lot more progress, and I think they've got something quite cool going. But I don't know if they've finished a race, because most of them have to stop and charge. So I mean, they finish, but in terms of being close to the ICE cars, I think none of the EVs have been too close yet. So that's really our challenge. Our challenge and our goal is to try to be close and competitive.
Yeah, the prize isn't just for finishing; the prize is for winning and beating all the other cars. So,
Oh,
Yeah.
okay. You have to win, not
You have
just
to win. You
Okay.
have to beat every ICE car there.
I see.
That's very, very challenging.
Yeah.
Yep.
And what's their pace per lap?
We race at High Plains out east of Denver. They're running about 215, 220 a lap.
Yeah.
We're hoping to get below 210s, which is going to be kind of tough, but yeah.
Even if we're in the ballpark on pace, that's where it really, all this comes down to how fast can we do the battery swaps and the pit stops, right? Even for the ICE cars, like the pace almost doesn't matter. It's all about how much time do you spend in the pits filling up and how much time do you spend in the pits fixing your car. So really these endurance races are won and lost in your stops time, not really in your pace.
Yeah. So like the winners last year did about 500 or 600 laps. So, and that's
Okay.
a 2.5 mile track. So,
And what now? Forgive me, layman's like, how do you win? Like, as far as you just have to have more laps at the end of the 24 hours than anybody else. Is that right?
Yep.
Okay. Wow. Super cool. Have you looked at some of the other EV races and looked at like how they handle it? There is a pack swap off-road vehicle. I'm not sure they finished anything yet, but there's they're doing the Baja 1000, I think. Do you know of them?
no, I have heard of someone did King of the Hammers with some Nissan Leaf pack swaps.
Yes.
That's it. Yeah, I think Talik Tyler, do you know who I'm talking about? They were at the Tesla takeover.
Oh,
See
I
if
don't
you
know.
See if you can figure that one out. And they got pretty serious about it. They swap an entire 400 volt pack. It's basically a whole Tesla, and it's a crazy system. It's like literally looks like a drill battery swap, but car size. It's like, and it just goes out the back. It's unbelievable. What do you got there, Kev?
This is an Elcon, but it's a 3,000 watt, 3 kilowatt charger. They make bigger ones. I saw something in the text about this. You need to get a bunch of matched ones, but yeah, these are basically disposable these days because people don't know how to reprogram them, but we know how to reprogram them for almost any voltage that you want. So you find a bunch of these, we got the secret sauce to reprogram them.
All right,
Oh,
yeah.
nice.
Let's keep.
I remember, I think I have a 5K for a project I was doing at the school.
They made a 5K. That's it's two 2,500 Siamese together. So
Gotcha.
that's what's in the
Pretty
tour.
Alex Maverick, what do you think of this project?
That's what I put my motor in my class 1 buggy. I built a class 1 buggy. I dropped out the LS engine out of my cage and put 355 horsepower in it, and at the front it a range extender too.
Oh, that's right.
Wow.
Yeah, you were ranging.
Yeah.
I almost forgot. Alex has done some racing. Alex, did you do swapping, or did you just charge with this range extender?
I racing with a gasoline engine in China.
Oh, okay. And what about the EV? Did you do a battery pack swap?
Yeah, it's a battery pack.
Oh, okay. And how did the swapping go? Did you swap and then charge?
Yes, but I have a more powerful onboard charge unit now. It's about 13 kilowatts onboard charge.
Oh, wow. Nick and Tyler, is there onboard gas generator backup? Is that a possible thing, or is that not part of it?
No, that's definitely not part of it. That's the running joke at the moment. But now we want to go pure EV and preferably charge from the grid instead of using a generator. So
You can't win the $50,000 prize if you got a gas engine in the car. You can't qualify.
Plus, that'll be a bad look if you're sitting there with a generator going by your stall.
yeah.
That's so funny. Yeah, totally. Wow, this is amazing. Homebrew, Justin, what do you think?
Oh, this is great. This is great. I can't wait to hear more. Best of luck, guys. I do recall when we went to State of Charge, there was a couple of guys working converting some big red Jeep Grand Cherokee for, I think it was some Baja race in Mexico. And yeah, just hearing all of the considerations I had to make for the battery swap and the fast charging and all of that stuff. I don't you guys are in for a big challenge there. You already know that, obviously.
Yep.
Super cool.
How
Johnny,
about the
go ahead.
monitoring of the batteries? Are you doing like remote telemetry, or is it in the cab, or that you're watching your BMS to see one cell is getting too low and things like that?
Yeah, so we have the Orion BMS running, and it has via CAN a display that we have up on the dashboard. So that'll give us error codes, and I think it gives us the lowest cell voltage and stuff. And then we record telemetry onto a SD card as well that we can review after runs.
Okay.
We talked about doing live telemetry as well, but we haven't really seen the need yet. And maybe as we get more competitive and want to be on the pit wall, figuring out exactly when to bring the car in and stuff, maybe that becomes a lot more valuable. But at this point, I think that's not been the top of our big problems to solve list.
Right. Well, yeah, but that would be cool to see while all of the battery stats as well as the motor, is the motor or controller getting too hot
Absolutely.
as you're beating this thing up. That could be interesting. So are you using Torque for the monitoring, or are you some other kind of some other app for monitoring the BMS?
We don't do any live. Everything just can log, and then the BMS basically, if it runs into a fault, will just kill power, and we have to address it. So, and we're pretty limited on what we can pass from the battery to the vehicle to get data out, just because of the connector. Well,
you got you got all the data you can use. So,
yes, I think we have some limitation. I honestly can't remember, but yeah, we can get all that data out.
Yeah.
So
okay. Well, you got the brain trust here if you need help on that. Lots of people have been doing things with that. So I've seen Torque used for monitoring that, the program Torque, which also monitors gas cars, and doing a project too for monitoring of the Ziva BMSs, which can be extended for others. But because I think rather than cut you off, you want to see like, oh, I can make it one more lap. I'm running on fumes. This battery's at 2.9 volts, but I think I can do it. You probably want that level of control versus it cutting you off like your car going to get groceries. So.
Yeah, no, absolutely. Yeah, I think that level of data and control is kind of what will take us from running to competing.
Yeah.
Sure.
Well, that would be cool. I got ideas, so let's keep in touch.
That's awesome. You know, we a couple years back, I volunteered to help with this car here at EV West. They had a pack swap situation where they had batteries that went into kind of like the mid engine of the car, right behind the driver before the rear axle, and they would just pull it up with a crane, move the car, and then drop back the next pack. But it was a short run, it was just a land speed run. And the guy who did the chassis is in the house tonight. This is Johnny 5. How you doing?
Hi.
All right. Johnny knows EVs and knows his way around a welder. So pretty cool. Oh, Sarah, thanks for joining. I'll see you next time. So anyway, Johnny, what they're doing is they're going to this 24 hour of lemons, and they're actually doing a pack swap, and they're trying to compete directly against the gas cars.
Sweet. That's the way to do it.
Yeah. And they're swapping the packs, and they're trying to swap as fast as possible. What's your limitation on the swap? Like, what do you find to be the biggest problem you guys are coming up against?
Me or them?
Oh no, the guys who did it, Tyler and Nick and John.
I guess in terms of swapping, it's just the weight of this thing. And if we want to be competitive, we probably have to swap in the hot pits. So we can't actually use a hoist or anything like that. Like, we got to get over a pit wall.
Oh, interesting.
I like the truck.
Yeah. Johnny's got a cool truck, similar vintage, right? It's a Toyota though, and it's got a Tesla motor in it. Pretty cool.
Awesome.
And then Ron,
What's that?
while you talk about that, Ron, I found the crawler in the chat. It's the
okay, perfect. So Johnny, what if just shooting from the hip? What would you do to make the pack swap quicker? And they can't use a crane.
Yeah, it's funny because I've been kind of thinking about that for off-road stuff for a while, like because you'd want to have something competitive against the gas cars.
Yeah.
Basically, like I would just cut that battery up into like 50-pound chunks. So basically like a 5 kilowatt hour pack at a time to where people can just grab it and kind of sling them in and out of there. I think that's honestly like the fastest way, I think. And even in off-road. Okay.
We actually thought about cutting it up, but because of the rules, we have a BMS on each sub pack, so that like the cost gets astronomical.
Right.
Yeah.
It'd be interesting if you could. What voltage are you running, or what motor's in there?
Hyper 9 HV net gain.
Okay, so you're like 144 volt.
Yeah. Yep.
7S on the or 36S, but what batteries are you running?
Jaguar I-Pace.
Okay, I've never messed with those things.
They're really, really nice from like a design standpoint and build standpoint. Like we have 14 modules and we slap them in versus thousands.
Okay. That's
They're
cool.
4S3P.
Right.
Hey there, you know what time it is. Time for...
Do those batteries take cooling directly, or do you have like a cooling plate that you run through?
There's a cold plate in the center.
That was how they were cooled OEM as well, right? As they were mounted to a cooling plate on the bottom. And then we took two rows of batteries and sandwiched the cooling plate in the middle to kind of try to package it tighter.
Nice.
So you're running a Orion BMS, you said?
Yes.
Nice. It'd be interesting.
The Zivas that I use are either 12 or 24 cells that they can monitor. That would make it a little more modular. And then they talk CAN to each other.
Yeah.
So Johnny, you would break it up into little pieces, smaller packs. That's one of the ideas you just had.
Yeah, I've been thinking about like how would I do it in an off-road situation, because when you're out in the middle of Mexico and you're trying to switch a battery, a crane's the last thing you're gonna have access to.
Right.
Plus it's slow. 4 guys in a minute or two can change a battery if they're chunks that are 50 pounds each. That's the quickest way.
We actually have a system that I can run you guys through if you want.
Yeah, let's do it.
Nice. Yeah.
So we essentially, oh man, where do I start with this? So there's going to be 4 contact points, right? So one side's going to be pinned in bushing. So you push the battery in and then you do 2 screws across the vehicle. Then the whole thing is going to slide on this like battery, we call it the battery spring plate, but it's basically just a frame on springs with rollers that's got enough force in it that will pick up the battery. So you approach from the side of the vehicle with the battery on a lift table, push it off the lift table, hits these rollers, rolls into the vehicle, engages the bushings on the other side, and then you just bolt the whole thing down, and it like compresses down past the springs and clamps. So wait, you guys still got me?
Yeah, it kind of cut out for a second, but yeah, you're back.
We need animation.
Follow. Yeah. I have
But
some
the
parts.
bed flips up. That's the first thing. Johnny wasn't here for that part. The bed actually flips back, and then the batteries roll out on rollers.
Oh wow.
Yeah. So then the idea is, yeah,
that's cool.
We have these hydraulic lift tables, right? So you can with the battery on rollers, it's really you want 2 people, but one person strong enough to push the battery out onto the table, and we could push the second battery back into the car.
We're like 40 pounds of push force, so
yeah,
enough for one person, probably 2.
That's a cool way to do it.
Sorry, what?
You should never have to lift this thing. So
yeah.
Nor do you want to drop it on your foot. So
how much does a battery weigh?
We're right around 500 pounds. So yeah, definitely don't want to drop it on your foot.
Oh yeah.
Are you roughly like 25, 28 kilowatt hours, something like that?
36 will probably get 25, 28 kilowatts.
Nice. It's about the same size as my Hilux battery.
Yeah, this thing, it's it's big, but it's pretty small comparably. Like the name of the game is efficiency, so lightweight, low power, just barely enough to get by and win.
Nice.
Are you guys limited to the number of swaps you can do, the number of battery packs you can have?
Only by our budget.
Okay.
Oh, that brings up a good point. So how can people support, like let's say people are like, oh, this is really cool. How can I like throw you some money?
Not something I thought of. Yeah, I guess hoping to get some sponsors, but honestly, I don't know how to go about that. So if you guys have recommendations, or if anyone of you would love to hop in and work on this thing, let me know.
Where are you located? Where's your workshop, or where is your, like, what city are you in?
So we're in Colorado. We're spread across the state. So I'm actually in Louisville, Nick's down the Springs. Like my dad's a machinist, makes parts for this season Springs, so it's all over Colorado.
Okay, forgive me. I know nothing. I'm the New Jersey guy that flies into Denver and drives up to Breckenridge. Where are you on I-70?
Northwest for Lafayette, Louisville, and then directly south from Denver for the Springs.
Oh, okay.
Yeah.
I got a buddy out there who's he's a Jersey transplant. He's an engineer, loves racing. Probably has he's got a machine shop, I think, in his house, and he's in the on the halfway between Denver and Breckenridge. And man, I should show him this project, dude. I usually visit him at least once a year, sometimes twice. And if I come out there, we could always lend a hand. Maybe he'd be into this. I'm not sure. And he just got himself a Tesla, so he's into the EVs, but he also likes the piston engines. He's into Subarus and whatnot. So
Nice.
yeah, that would be real good. I think that's the right idea. One of the things I suggest you do is maybe an overview video, just explain. That's kind of what this is anyway. But you could use this on Instagram, or is there a website that you guys have for more info?
Nope, just an Instagram at the moment.
Okay, well, the Instagram works. That's fine. I think you sent it to me. What is the Instagram again?
I think it's Team Arc Blast.
Oh yeah, that's right.
Yeah, the goal here is we would definitely want to make probably some videos, spread information. Like this isn't so much a business to us. We want to get people into racing EVs. Like we want some competition. So
that would be cool, man. Well, maybe that would happen this summer. What a cool idea. I like that it's kind of DIY, and it's kind of like, the joke is that it's rough around the edges and it's just, you just get it done type of thing. This would be cool. Johnny,
Yeah,
what do you think, man? We compete against these guys in the summer?
I got enough projects going on.
Yeah, there's a lot going on. Yeah, that's
But
true.
So when is the race? Did we cover that?
Oh yeah,
Yeah, so-
when's your next race? What's going on? How do we?
Yes.
Like, we want to support you. So where do we?
Yeah.
How do we follow on the next race? Tell us.
Yeah, so where we are is, for the race at the end of last summer, we're targeting passing tech, getting a couple laps in. So we've done that. We've now done another track day or two, kind of tuning the car some. But as we've talked about, for sure, there's still so much to figure out from a charging point of view. We need to do aero to improve our efficiency. So, we're through like the first hurdle of having a running car, but there's all the other things that we need to do to be competitive now. Our target is to do the 2 High Plains races this summer. If we look at the schedule, that's
June
July
15th. June 15th, 16th.
Yep.
Followed by
Then
September 14th and September 15th.
Yep.
Deer Trail,
first.
Colorado.
Mhm. It's at High Plains Raceway, which is it's actually a really cool track with a lot of elevation changes and stuff. It's
You
a
have
really good
an
time.
advantage because you're EV, so you don't have to worry about the air density.
Mm-hmm. Yeah, the track's at about a mile high.
That's crazy. That's so wild. Okay, so you get ready for this race. What do you got to do to get ready? You don't have the other batteries yet, right?
Yeah. Build 2 more batteries, build all the charging, and do aero. I think that's the main bit, right, Tyler?
Yep, and I have to finish redoing the motor mounts.
Yes.
What
also-
kind of? Oh, go ahead.
Oh, I guess we haven't mentioned this is all Miata NB or NA Miata suspension, so we're gonna have to do a little bit of work there to like tune it as well. So
Okay.
Are you allowed to have sponsor stickers on your truck in Lemons?
Yep, there's
Okay.
a thing around having themes, like they do. It was like the best costumes or best themes awards. We're not too focused on that, so we can put whatever we want sponsor wise.
So if it clashes with your color scheme, it wouldn't bug you too much. Because we know Jehu Garcia also, and he's got batteries. So maybe he would sponsor. We also know people at Thunderstruck. So
Awesome.
Okay. Yeah, that would be really interesting.
We know people that know people.
that too.
I'll have my people get in touch with your people.
We got people who take care of problems for us too.
So the amazing thing is that you're doing this. It's so cool. What was I gonna ask? Oh, I have a very layman's question here. When you're driving that truck, you got the net gain motor hooked up to a transmission still, or are you going direct? What are you doing?
It's direct.
Really?
Direct
Yep.
to it's a Miata differential in the rear, right?
Yep. So
Interesting.
that saves us like about 200 pounds, I think. So it's pretty gutless from a standstill, but when we're running 40 to 100 miles an hour, it doesn't mind.
So where is the lag in the beginning, right?
Yep.
So what is it equivalent to, like, let's say fourth gear maybe, or fifth?
Probably fourth or fifth. I think we're at a 3.9 to 1 ratio right now, direct. So it like it's from full throttle at no speed. Like you could run faster than this thing.
Oh wow! So you have no. So what about getting out of the corners? What do you do about that, man?
Yeah, so when we're in the corners, we don't go below about 30 miles an hour, so we have all the torque we need. It's just a balance of the weight loss or the weight we save without a transmission versus the torque we lose. So part of what we need to do is change the rear end gearing to, I think we're gonna go 5.3 from 390, a little bit more torque.
And frankly, from a pace point of view, none of the Lemons cars are particularly fast, and so we're not planning on being particularly fast either, right? It just needs to be fast enough to be in the ballpark on pace, and then we just have to get the stints as long as possible, so get the efficiency up as high as we can, so we can run as long as we can on a pack and minimize our time in the pits.
Is there a speed limit? I have dumb questions. I have layman's questions here. Is there a speed limit between turn 3 and 4?
Speed limit? No, it just flat out. I think
so. Are some people like, what if someone's got a big fat V8 and like a light car? Are they just killing you over there?
Oh yeah, they'll do 110, 120.
But that's it. They won't get higher than that.
It's whatever the limit of the car is, right? So if these are pretty cheap cars, they're not going to go terribly fast.
Yeah,
right. Like, you got to be ready for that turn. So yeah,
on that straightaway, I have a Mini Cooper that I race, and it's just like a stock 2012 Mini Cooper, and it'll hit about 112 on that straightaway. It's not actually that long. I think Corvettes, like they'll hit like 130, but we're not racing Corvettes, right?
Yeah. Wow. Interesting.
Yeah. And
wait, are there
what did we hit
on the track with you?
In Lemons? None of the new Corvettes are anywhere near the realm of
I see.
price competitive.
These cars have to be like old cop cars and stuff like that. But those are
C4 Corvette that's clapped out. Maybe you can come out and race with it.
And at the most, maybe Lemons cars are going to hit like 115 or so.
But did you see the Blues Brothers?
Yeah,
they can jump over like entire, the bridges, man. Yeah. It's got cop tires,
the LPD,
cop motors. So who's your scariest competitor? Because I don't know much about these races. I just know that they're $500 or whatever. Who's your scariest competitor?
Ourselves.
All right, fair enough.
That's the answer I was expecting. I mean,
Yeah,
I think it would be commendable to even finish this race would be commendable. There should be a prize for that.
Yes,
As an EV, you finished the race. So it's.
I think it was the Duff team finished the race. I think they did maybe 200 laps. Don't quote me on that, but finishing one of these races is not terribly difficult. It's finishing and being on the track the whole time that's difficult.
If we could go out and run a 24-hour race and not have anything break and the battery swapping works, so we're vaguely in the realm of competitive, that's where we're trying to be. I think that would be awesome. And then from there, then we can see, what we can actually do performance wise, efficiency wise, whatever that we need to do to try to actually win. But just getting even in the ballpark of competitive is still such an uphill battle at this point.
Oh no, yeah, I totally 100% behind that. Yeah, you got to go practical first. Have you thought about like a two-stage, like a I don't know, maybe Johnny knows what these are called, but after the transmission, there's like not on yours obviously, but in drag racing or some applications, there's a an overdrive gear. It's kind of like it changes your final drive, and it's like a push button or just a one lever. And they sell these. What's that called?
Like a Lenco transmission?
Yeah, what Lanco? Is that it?
Lenco, something like that.
Lenco. Okay.
They're probably they're pretty expensive.
Oh,
yeah.
Okay.
I mean, we could add one of those, but we want to keep it simple, especially right now where we're trying to like develop, right? Not to mention, if I were to extend the length of that setup anymore, we'd have to put the motor in the cab. So,
okay,
Less
no, fair enough.
Fair enough.
Okay. Super cool. We have some questions from Richard Jones. He's an EV guy. Richard, do you want to fire away, or you want me to read these?
Yeah, I'll fire away. Two questions. I'll ask the first one, then ask permission for the second. On the aero, you said you're focusing on aero next. What other efficiency factors do you think matter? Like, for instance, tires, things like wheel bearings. I'm curious about efficiency.
Yeah, I mean, like wheel bearings and like rolling resistance are definitely important, but it's a little awkward. Like, we're not going to go buy Honda inside tires and throw it on here. We have to have cornering speed. So
there's
rolling.
Sorry, just to chime in there, right? Because there's a trade-off. You can decrease your rolling resistance, but then if you lose more speed in the corners, you're now increasing the amount of power you have to spend digging out of each corner. So there's some kind of trade-off between sticky tires and like EV tires, and quite frankly, I think there's probably a lot of testing that needs to be done there. But we're kind of leaning on we're running the just kind of endurance track tire compound right now. That's pretty sticky, but not crazy sticky, and it's definitely not the lowest rolling resistance. But we think keeping momentum in the corners is quite critical.
Yeah. At this point, I would argue it's better if we ran at 70 miles an hour the entire track and never slowed down than having better rolling resistance. So, in terms of aero, last we tried to calculate this, I think we're at like 1.6, 1.7. Like we're worse than a brick right now.
Well, you need a tonneau cover or something like that, but that's going to slow your battery swap.
Yeah. We're actually we can put a bed cover because it hinges up, right? So the whole cover will just hinge up out of the way. Then doing like a flat bottom or something just to like smooth up everything. We're not too worried about downforce. We just need to be slippery. So.
Okay.
Best shape for that.
Yeah.
What's that, John?
It's the best shape for that. It's just like the Hilux.
Dude.
Slippery as a brick. Yeah.
Yeah.
And Richard, you had another question?
Yeah, just going back to the drive ratio, it was very interesting that you don't go below 30 miles an hour, so you're not too worried about an 8-to-1 ratio. So that ratio change you are planning on doing, is that something you can simply do by swapping gears in the diff? Or how are you And what number were you getting to again with that? Because this is very close to my heart with what I'm learning for planning.
Yeah. So yeah, everything gear ratio wise would be in the diff. Right now we're running a 3.9 Torsen, like Miata diff. You can run, I think it's an RX-8 5.3 to 1. That's going to put us probably over speed on the Hyper 9 at like top speed. We'll probably be doing like 9 or 10,000 RPM. But right now we're topping out about 86 miles an hour. We're not even getting close to 8,000 RPM, which is the, like, rated maximum for these motors. So we're just not getting enough torque at the top end.
And we're
ideally
drag limited there too, right? So increasing aero efficiency should hopefully help bump that up a bit too.
Okay. Richard, you got a follow-up? Did that answer it?
No, that's good. You said RX-8. Does that mean you have to put an RX-8 diff in there?
I'm fairly certain RX-8, but it might be something else. But they should be just a direct swap ring and pinion, and it fits in the case. So
there's definitely
you have a Miata in there now, and you would put the ring and pinion from a RX-8 to get you up to 5.3.
Yeah, they're both Mazdas, so maybe it's shared case and different gearing.
Yep.
Yeah, I don't remember if it was the RX-8 or not, Tyler, but there's for sure something in the Mazda family that fits in the same like housing.
Yeah,
thanks. That's interesting to know. Just because I'm maybe going to go along the path of a direct drive myself, if I can't fit a diff in the back of my tiny sports car. So thanks. Good information. I appreciate it. I'm done.
Okay. I guess one note, we're gonna make it car, like definitely have a transmission or something, because you're not gonna get any acceleration from a stop. So
yeah.
And that was going to be one of my questions: is did you keep this as a legal street car that could be registered in your state, or you think you're too far gone at this point?
We should be able to. It is actually registered, but it's not streetable. I'm pretty sure we meet all the regulations, but I'm not even going to try at the moment.
Yeah,
I think the only thing we were missing right now is a horn. So that'll be an addition later here, and maybe we'll try to get it on the road.
I have
right. Well, you said if it's so slow off the line, I guess that's going to be a problem anyway. So
yeah, it wouldn't be particularly fun, I think, on the road. It's just not sort of what it's built for. It's also really low, right, Tyler? Like,
yeah, right. With where this motor is mounted, we have about 3 inches of ground clearance. So
oh wow,
right, which is fine for the racetrack, but not good for speed bumps.
Or putting you on a trailer.
Driving potholes in Colorado. I have a very dumb layman's question. Why even have the back at all? Is there rules to having the sheet metal on there? Can you just take everything off of there?
There has to be the crash structure still intact. So like we made modifications, we're gonna have to get them like approved. There's also rules about how far away the battery has to be from the outside envelope of the vehicle. I think it's 9 inches right now. That's just like penetration protection. So if you get hit, and lemons being lemons, you're gonna get hit. Like you don't want to puncture the battery.
Oh, interesting. Have you guys rubbed with other people on the track?
I mean, not in this car, but in other vehicles, yeah, it's happened. Rubbin's racing, as they say, but try not to do that.
Yeah. This is fantastic. Geez, I'm sure there's a million other questions. We actually had some people just join now. If they'd like to jump in and ask some questions, we've got Zachary. If you'd like to jump in and ask some questions about this amazing project, go ahead. Alex, you got any suggestions for us or questions? We'll take them. As we I guess we'll kind of wrap it up from here. I really think that the journey is the exciting part about this. I'm so glad that we got in here at this stage in the game. We have a question from Richard. Richard, go ahead.
I said, so you're using a Hyper 9 right now, right?
Yep.
But if you had an open checkbook, what would you use instead?
Wow. Honestly, probably a Model 3 like rear drive unit and a pack. But like it's not just cost at that point, it's like manufacturing time, our time to build it. So honestly, I kind of like where we're at. It's just enough that we should be able to do what we want to do. So
Is there,
And
is there
part of the
anything,
reason with
is there anything that would form factor replace the Hyper 9? You know, since you've got it all packed in there right now, is there a beefier motor out there that sort of could be an upgrade from Hyper 9 in the same form factor?
I think there's a few motors that use the same. I think it's the B face motor attachment. A lot of them would fit. I'd have to do a little modification to the motor mounts, but nothing comes like it. I don't have the brand names off the top of my head, but there's several other motors that would fit. The voltage architecture becomes a problem. Like if we had to go to 400 volts, then our battery gets bigger. So
yeah, and part of the reason of picking the Hyper 9 was the voltage, right? Because we were able to get this pack in a packaging where we can meet the 9 inches from the envelope of the car and make it in a form factor that we could swap in and out of the car. And yeah, getting up to higher voltages, that becomes a really big challenge unless you go with kind of a totally different battery architecture.
Yeah, the next evolution would be 2 Hyper 9s.
Oh yeah, I was about to say that. Would that be the in between to go to dual?
I mean, anything's possible, right?
I guess it's a trade-off of performance versus efficiency too, right? Like, because efficiency is so critical here. Really, I don't think the issue for us is going to be performance or speed. We're, even just in our first runs, we're in the ballpark of the pace we want to be versus the Lemons cars. It's really a matter of getting our stint time up, and I don't know how much extra power or extra motor would help with that.
What did you call it? Stint?
Yeah, sorry, duration of one battery. You call it, typically you call it stints in endurance racing, and that's how long it takes between fuel fill-ups.
Yep.
And so
Got
you go
it.
out and stint is, I don't know, an hour and a half or whatever it is for your car at your track. But for us,
Okay, I got you.
it's battery range as a time, right?
Yep.
Let's go to Justin. He's got a question. Go for it.
Sure. Well, Drew, right now, you just reminded me of something else. Are you going to have a driver change with each, battery pack, or maybe a driver can go for more than one?
Yeah, so we'll probably do a driver change with each battery pack. From a safety standpoint, Lemon's rules, like we can't have a driver in the vehicle when we're swapping. So
Okay.
we'll probably do just a full driver swap instead of long stints.
Gotcha.
Or
Okay.
maybe we do two batteries per driver after a while. We'll see what makes sense. I think comfortably, we've both done maybe 2 hour stints before, so
Yeah.
we'll see.
Cool.
Some teams will run up to like 4 hours per driver before they swap. So
Yeah, it's intense.
We didn't even talk about running at night. It's 24 hours. What's your lighting situation about?
I think one of the pictures we sent you has the car in the evening.
Yep.
But is that it? Just those cool lights in the front? Or is there anything more to it? Because I remember when I was when I did some quad racing out in the desert, and man, you had to have some lights.
Yep.
I guess it's a little different because we were in the middle of nowhere. We were in Nevada,
Track is
in the
lit.
back fire roads.
Yeah.
Yeah.
Yeah, we do need some more lights, but these are just OEM replacement LED lights. Like trying to keep it pretty low power, but just enough light to see.
And obviously, you're running a 12-volt system as as your low voltage.
Yep.
Yeah, so we've got a DC-DC to charge it while the high voltage battery is connected, and then all of the lights, the safety stuff, gauges. We have a USB charger in the car for the GoPro, stuff like that's all off the 12-volt system.
Okay. Justin's got another question. Go for it, Justin.
Sorry, one more. This one's a little bit boring, but Ron, we had talked about this in the past. Like scheduling and planning. So, are you guys are there milestones that you're trying to hit? Have you tried to schedule at different either component design, racing sessions, practice, etc.? How's that all going?
I'd say we have milestones and goals we try to hit, but it's just us in a garage. We don't have a serious timeline or a schedule. Yeah.
Yeah, it's mostly just whenever we have time to work on it outside of our full-time jobs, right?
Fair enough. Yeah.
I think that the next big milestone for us is really the Lemons race this summer, to really try to fully finish the 24-hour race with the charging. And I think from there, there's not really too much, at least on my radar, Tyler. I think from there, it's just a matter of competing more, being more competitive, and trying to do more races each year.
Yeah, I mean, at this point, like, milestones are make another battery pack, make the charger, test it.
Yeah.
The race is really going to be, we're going to find out if this is possible for real. Like, we know the math says it can do it, the data says it can do it. Now, can we do it from a logistics standpoint?
Yeah.
How much time would you guys say you've spent so far?
Years. I guess, yeah. So I wasn't working for about a year there, and I was working on this almost every day for about 6 months.
Wow.
So like this took quite a bit. We finished it 2 a.m. Thursday night before Friday tech. So
pressure. Yeah. No, I think I just want to riff on what Justin's saying, is that, like, sometimes what I do with student projects, well, not sometimes, all the time now, is I come up with like a schedule, and I also have a parallel schedule. Like, what can people do in parallel? So, for instance, last summer we did this big bus project. There was so many people, and we had to get it done in a certain amount of time. And so we had this front of the bus, back of the bus, a bench top, and then also off the bus, like like software, stuff like that. And we kind of had this schedule going, and I recommend it to people, because what happens is they might put something on the schedule and they'll do kind of a little bit of nothing until you get to the end. And so if you set up these milestones, the waves will be bigger, and the area under the curve of work, so to speak, will be equal a lot more than if you waited till the last minute. So, but I do think you are kind of doing that, where you're like, okay, well, let's get to the track and qualify. Okay, done. Now here's the improvements we're going to make. And so do you guys have a list, and how many people do you have helping you?
Oh, yeah, we definitely have a long list now. I think there's 5 of us currently. We got the 2 of us. We got my dad, the machinist. I got a fabricator who's helping us. I got someone with a little bit of aero experience helping out. But like I said, we all work. It's just anytime we have after work, a Sunday here and there, just try to get it done. So
yeah, that's cool. No, it's a good question.
And just one more thing I want to add to that, because we did definitely have a bit of a ramp up sprint before the race last summer to get the thing finished, and I had a week off of work, so that kind of is where naturally I had the time to help. But we went from not a single wire in the car to the full car running within a week and a half.
Wow.
So there's definitely been some sprints as part of this, but we've gotten past kind of that first big wave, and we're hoping to smooth out the rest of the waves now.
Nice. It's cool stuff. As we wrap up, I think the value in what you're doing for other people is the story. So Instagram's a kind of it's a pain in the ass, but if you guys could give us like little updates, and even if it's simple, like, hey, here's what's going on today, we're going to do this thing. It doesn't have to be Instagram worthy. It just has to be enough that we the people following you, people on this call basically get to see what the next step is, or how we can help out. So very cool.
Yeah, for sure. Let's put some work into our communication here.
Yeah, don't work too hard. Just hit go, because you guys are pretty good about explaining it. And then if you think about it too much, that's going to be like that, that's what makes it hard. It's social media, is really good, but it's also like you're like, oh, is that good enough? There, just post it. Don't worry about it. We're not winning awards here for that. We're just trying to follow your story, and it's just a great way of communicating. So, pretty cool stuff here, man. Guys, it's very cool. Does anybody have any other questions they want to jump in here, add some stuff? Okay. All right. We'll wrap it up here. So cool. And man, I can't wait to see this. So let me just one more time. The next race is going to be in Colorado, Highlands Plains, right here. Oh, is this
Not
right?
that one. No, that's the second race. The first race is up a little bit. It's
Right here.
June 15th and 16th that weekend.
There we go. Oh, that's actually pretty cool. All right. Full 24 hours. There's spectator tickets. And where is Deer, Colorado?
It's like an hour east of Denver.
Oh, okay. That's cool. Nice. And if someone goes as a spectator, like, do people really stay there 24 hours?
Yeah, pitch a tent.
Really? Oh, yeah. Why not? Yeah, hang out. Right. Oh, that's where the RV comes in.
Yeah.
That's pretty cool. All right. Well, cool. We'll wrap it up here. Awesome. Thanks. Oh, Zach's in the house. I didn't even recognize the name on there. Zach, you got any questions about this guy going racing? Come on.
Hey, Mr. G. Sorry, I joined super late.
That's okay.
Pretty cool. So I totally can relate with the options thing. You know, when you're looking for something that's like a Hyper 9 alternative, but maybe a little beefier. I'm trying to work on it. I'm working on it. I'm trying to get better options for everyone from my connections in Taiwan. I guess my one question would be if 400 volts wasn't an issue, like let's say there was like a magic battery option. You know, would you consider other motors besides Model 3?
Definitely. It boiled down to efficiency at that point. What's going to be the most efficient over the widest RPM range for us?
What's like the top RPM like you would wish for?
Ooh, probably no more than 10K for this application. We're not running a transmission, so just whatever the ratio is in the rear end.
And we can tune that to what motor we're using too, right? There's really a range that we can dial in.
Gotcha.
Yeah, what I'm getting from the conversation so far, it's like it all depends on what is the most efficient and what will fit. And the battery packs are limited and how close they can be to the outside of the car and things like that too for crash. So if it was the right ratio and it was the right RPM and everything else and efficiency, it could maybe work.
Nice.
And Zach, they accept sponsorships if you come up with something.
I need sponsorship as well, unfortunately.
Yeah, I mean, basically, it's pretty wild that on the call, two potential, motor manufacturers are in the house, Zachary and Alex from Maverick. So you guys should all stay in touch and definitely check it out. We also have Justin with a last-minute question. Go for it, Justin.
Sorry, I can't stop tonight.
No, it's okay. This is good.
How are you guys working together? And like, what are you working on? You mentioned you're a few hours apart, right? Are you focusing on like the design stuff, Nick? And
so
work? I don't know. You tell us.
So I'm more the mechanical side. So like I figure out the suspension, how we're getting the battery pack in and out, motor mounts.
Okay.
Nick is more on the controls and the electrical side. And then we just have a Discord server, and then he drives up here every weekend right now to get this done. So
wow.
Okay.
Awesome. Cool. Yeah, if you have a goal, people will rally around it. What's that movie? The Field of Dreams? If you build it, they will come. And having said that, we should wrap it up. I feel so lucky that we get to do this. This is so awesome. It's great. I love catching up with the whole EV community and seeing wild projects like this. Good for you guys for trying to put an EV on the road with the gas cars. And these guys probably laugh their butts off watching you guys swap packs and struggle. Well, they're going to be pointing and laughing until they say, hey, where do I get one of those? So
Right.
I mean, it's just awesome. So, all right. Well, thanks a lot. We'll wrap up the recording right here, Mr. G's EV Hangout. And we'll probably hang here for another minute, but I'm just going to stop the recording there. All right. Sounds good. Okay. Oh, Talik, is there anything we should add at the last second here? I forgot.
I think we're good. That was a good whole thing. Very exciting. Love to see more stuff in the conversion space when it comes to racing, because then you got to push yourselves.
Yeah, dude. Well said. Absolutely. All right. Talk to you guys soon.
Yeah, best of luck, you guys. Thanks a lot.
Yeah. Thanks, Jay.
Awesome what you're doing. Very inspiring.